In this exercise, we'll solve an inequality. The inequality is 5 minus 9x is greater than or equal to 19 plus 5x, and we're going to write set notation for the answer. Now, let's rewrite this inequality with the x terms on the left-hand side and the constant terms on the right-hand side. So I'll begin by subtracting 5x on both sides of the inequality to eliminate the x term on the right-hand side. So we have 5 minus 9x minus 5x is greater than or equal to 19 plus 5x minus 5x. Now on the left-hand side I have 5, and negative 9x minus 5x gives me negative 14x. So I have 5 minus 14x, and that's greater than or equal to 5x minus 5x is 0, so I have 19 plus 0, or just 19 on the right-hand side. Now I want to get the x term alone on the left-hand side, and I can do that by subtracting 5 from both sides of the inequality. So I'll have 5 minus 14x minus 5 is greater than or equal to 19 minus 5. 5 minus 5 is 0, so I have negative 14 times x on the left, and that's greater than or equal to 14. Now to get x alone on the left-hand side, I can divide both sides of the inequality by negative 14. And when I do this, on the left I have negative 14x over negative 14. Using the multiplication principle for inequalities to do this, I know that when I divide or multiply both sides of an inequality by a negative number, I have to reverse the inequality symbol. So I'm going to reverse greater than or equal to and write less than or equal to. And on the right I have 14 divided by negative 14. On the left, let's continue over here. On the left I have negative 14x over negative 14, which is just x. And that's less than or equal to 14 divided by negative 14, which is negative 1. So I can write the solution set in set notation as the set of all x such that x is less than or equal to negative 1.